Hello and welcome back. Let's continue our class of soil mechanics. So before we start this video, I would like to make an announcement for your information. After this video, all my video about this program will be private videos. Okay, so if you want to continue watching, please send me an email or a message on WhatsApp, or just make a comment in one of the videos. Okay, yeah, only those who I will allow to watch will be able to watch the videos. Thank you. So we will continue this chapter number 6 about soil compaction. And this chapter has this content. I think last time we did introduction and general principle. In this video, we will talk about standard Proctor test, which is a very important test in soil mechanics, geotechnical engineering. Okay, so please try to be focused and learn something. Let's go. So standard Proctor test. What is this test and how do we do this test in the lab? Okay, so this Proctor test is done with soil, which is compacted in 944 cubic centimeter mold. And this mold has diameter of 101.6 millimeter. Okay, these are like standard dimensions of the mold. Okay, and the mold is secure with a base plate at the bottom and extension at the top. Okay, we will see this. There is figure that will show what I'm talking about. So the soil is mixed with various changing the water content of the soil. So varying the water level, and the soil is compacted in 3 layers. Please remember that is important. 3 layers, and we use a hammer of 2.5 kilogram to compact the soil by dropping the hammer from 30.5 millimeter. Okay, and for each soil layer, I told you, remember that there are 3 layers. For each layer, we do 25 blows on each layer. Okay, and this one, number 1 and number 2, are showing like schematic view. This is the mold, and this is the hammer actually, and this is just a photo. Okay, so this mold, as it said here, 944 cubic centimeter. This is the volume. If you want, you can calculate also, because you have here the diameter is 101.6 as stated here, and the height of the mold is 116.4 millimeter. So you can calculate the volume if you want. Okay, so this is the base plate at the bottom. Okay, which is here also in the photo, on the photo, and this is extension just for safety, so that the soil will not drop anyhow. So this extension can be removed, of course, and I will show you at the end of the test. You have to remove this extension and continue to be able to continue the test. Okay, so the hammer is inside this, what you are seeing here. Okay, inside this thing there is a hammer like this. The hammer is like this, and the weight of this hammer is 2.5 kilogram. Okay, and the height, see, from here to here, it's like you will pull this handle, pull, and you drop. So the height is about 305 millimeter. Here it's not 30.5. Okay, sorry, we have to correct that. Let me correct it better. Or if you do that, you have to put in centimeter. Okay, all right. These are the equipment you need to do the standard Proctor test in the lab, in your lab. Okay, you got it? Is it okay? I think there is nothing difficult to understand here. Yeah. So how we do the test, don't worry. I will explain this later. Okay. So I will just keep this here and let's continue. Okay. So for each test, you change the water content and you weight the wet unit weight, the moist unit weight. You obtain that. Okay. For each test, the wet unit weight of compacted soil, of course, we call it, okay, gamma, just gamma, okay, can be calculated. And how do we calculate that? By using just this formula. Okay, the weight divided, you divide it by volume, because unit weight is just weight divided by volume. Okay, this is how you get the weight. And you, to get the weight, you can just go and weight this mold. Of course, you know already, you can know the weight, the self weight of the mold, means without soil. Okay, the empty one, you weight that first, you know the weight. So no need even to give you the weight here, you can do it by yourself. And then you weight also the mold full of soil. So the weight of full mold minus weight of empty one, you get the weight of your soil. Okay, and the volume is already given, 944 cubic centimeter, right? So this means, let me check something. Okay, let's continue. So the volume is already given, as I said, 944 cubic centimeter, or you can calculate the volume here. Please don't include this part. Okay, the volume is this one and this one, because you will not need that part. That part will be removed. Okay, but just use the given volume. This one, let me go back a little bit to show you what I'm talking about. Oh, sorry, this one, 944 cubic centimeter. Okay, so then you can calculate the unit weight for each test, because you will change the water content for each test and see how the density, the unit weight will change. Okay, so from this formula, it's easy to obtain the unit weight. Then, of course, this is the weight of compacted soil, not the, it doesn't include the weight of the mold. Okay, only the weight of the compacted soil in the mold. The volume VM is the volume of the mold. Yeah, it's written here, 944 cubic centimeter. Okay, so, and then for each test again, you can determine the water content of the soil. Okay. The value of water content is very important also. And after that, if you know the water content, the dry unit weight can be calculated. If you know water content, you can easily obtain the dry unit weight. How do you do that? By using this formula. So dry unit weight equal to unit weight, this unit weight, okay, plus divided by this 1 plus the water content you calculated. Actually, the water content, you determine it. How do you determine the water content? It's easy. Just the weight of wet soil minus the weight of dry soil. Then you will get the weight of the water in the soil. The weight of the water that was in the soil when the soil was wet. That easy, right? So don't worry, we will come back on this and explain everything, how to do the test itself, okay? From this formula, you can obtain the dry unit weight. And if you remember, this parameter is very important. This is water content, okay, in percentage. And the dry unit weight, you remember, okay, we said in the previous video, the extent of compaction is gauged by the soil dry unit weight. We can judge if the compaction is good enough by using the dry unit weight. Actually, it's the dry unit weight that is used to judge if the compaction is well done or not. So just to make you realize the importance of the dry unit weight here, please remember that. Okay, so obtain your wet unit weight by doing the weight. You will weight the soil, and I have explained how to obtain the weight of soil. Weight of the full mold minus weight of the empty mold. You obtain the weight of your soil. And the volume is constant. It doesn't matter what type of soil you are using or what type of the amount of water you have added. This volume is same because it's the volume of the mold. So weight divided by volume, you get the wet unit weight. And you obtain the water content. To do that, weight of the wet soil minus weight of the dry soil, you obtain the amount of water, the weight of water that was in the soil. And then weight of water divided by weight of, I guess you know how to obtain the water content. Okay. Okay. Weight of water divided by weight of soil. So if you obtain the water content and you have the wet unit weight, you can obtain, by using this formula, you can obtain the dry unit weight. That is the most important part. Okay, let's go. I will just keep these two formula here. Okay, so the value of the dry unit weight estimated in this equation 2 can be then plotted against the water content to obtain the maximum dry unit weight at optimum water content. Do you remember that? The maximum unit weight, that one is not easy. It is not difficult to remember. Okay. Maximum unit weight, the optimum water content Okay, the curve will be like this. And this is an example of this kind of curve. This one, you see, this one is for silty clay, for example. So you can see here the optimum water content, the optimum moisture content is here, and maximum dry unit weight is here. So it means for each test, because you will change the water content, changing water content. For each test, you will obtain a unit weight, a dry unit weight, and water content, and you can plot. It will be like this, like this. It doesn't mean that you have to have this point. You may not have this point, but after you can just try to approximatively, because if you get a point here and another one here, it means the maximum one, the optimum one is around here. So you can plot easily. All right. So this is the objective, the main objective of this test. By doing several tests, by just changing the water content and obtaining the dry unit weight for each test, you can get this curve. And getting this curve is the objective of this test. Okay? Please remember that. Let's continue. So the procedure for doing this, dealing with this test, is explained in the American Society for Testing and Material. This is designation, and also in the ASTO with this designation. So you can go and check. It even available online. You can check by yourself. But here I will try to explain a little bit how this test works. Okay, how to do this test, how to perform this test. Okay, so this is the procedure of standard Proctor test. Okay, so this is just I try to explain this from this drawing, and I hope it will be easy for you to understand. The first step is about this. You see, this is your soil, and this is the water. You mix the water and soil in this small container. Okay, it doesn't have to be small like this, but you add the water each time you add the water. But be sure that for the first test, don't put too much water, of course, because you will be adding water again and again and again. So make sure that you have enough soil in this container. Add water and soil in the soil and mix them. See this? This is mixing tool. Mix this soil in the water properly. Mix it very well. And after mixing it, you use now the mold. Okay? You put this water, the soil, the mixed soil, the wet soil now, because the soil is mixed with water. You put it in the mold. Okay? And don't remember, you want to do 3 layers. So don't put too much. Okay? But of course, when you compact the soil, the volume of the soil will decrease. Okay? In that case, that's why sometimes this is for professional. But anyway, try to obtain 3 layers. So this one is about like this. So in this one, okay, it will be exactly like this. The extension, you have to use it in that case. Okay, fix it very well, and you put the wet soil inside in the mold. Okay, and then you start your compaction. The hammer, I see the handle, you pull up the handle and don't push it, just drop it like that. You pull up to the limit and just drop it. You should not push. Okay, like that. And you will see that you do again, first layer, 25 blows. you hit it 25 times. So for each layer, 25 blows. So it means you will repeat, you see these arrows, you will repeat this 3 times. Okay, you put soil, you compact, 25 blow, you put again 25 blows, and you put again one last time, and you drop the hammer 25 blows. It will be at the end, you will obtain something like you see this. The hammer is inside, like this thing. Okay, do you see the hammer is inside? So if we try to see what is going on inside by cutting, you can see first layer, second layer, third layer. Okay, it's difficult to make all the layer same unless you are very professional one. But you pull the handle up to end. The hammer comes to the end here, and you drop it. You drop the handle. Okay, and you drop the handle. Here again is this. See, from here to here. Can you see what is going on? This photo, maybe the photo are not very clear, but you can see we are putting here the soil in the mold. Okay, after putting now, you start compacting. See, the guy here is pulling the handle and dropping. And while you are dropping, make sure that you drop the hammer everywhere in the mold, at the surface, not only on the middle. As you can see, here is the middle, and here, for example, is the side of the mold. So be sure to compact all the soil. Okay, and after that, what you do after doing this, at the end, 25 blows each layer. Then what you do is this. Now you see the amount of soil above, you will remove, because you will remove the extension after finishing compacting the last layer, the last blow of the last layer. You can remove this extension. After removing the extension, maybe there will be some soil above that is higher than this part, this mold. So you just use, there is specific tool like a ruler to make it flat. Okay, something like that. This is what is illustrated here. See, you remove, you take off the extension, this part, and you use this tool to remove the any extension of soil here, because we want it to be very flat so that the volume will be respected. Okay, then after that, what you are going to wait, because please see this formula, you remember this formula. It's supposed that you know the weight of the mold already. The empty mold, you know the weight it weight. So you will go to weight this mold. Then you take it and you weight it like this, and you have the value of the weight, how many kilograms or something like that. Okay, then from kilogram you can go to Newton, right? By using the gravity, multiplying by gravity, 9.81. Okay, if it is the weight you obtain, you multiply it by 9.81 to obtain the weight in Newton. Okay, and you can convert from Newton to kilonewton. I think these are basic things you know since maybe high school. So if you weight this mold full of soil, the weight you will obtain, you minus the weight of the empty mold, because that is supposed to be known. Or if you don't know the weight of the empty mold, you can start by weighting the empty mold first before even starting your test. That is recommended. Okay. And if you have now the weight of this wet soil by doing weight of full mold minus weight of empty one, you can then use the volume 944 to obtain the unit weight. And by using the wet unit weight, you can obtain this dry unit weight. But before obtain the dry unit weight, you have to obtain the water content, okay? And how do you obtain your water content? That is easy. You just take, you don't need to take everything. Cut a part of this soil in this mold, the wet one, okay? And weight it and dry it. After drying, you weight again to know the how many grams or kilograms. Okay, do you understand? Because this wet soil in this mold now, you don't need it. Same here, you don't need to to dry everything. You have, of course, the weight, the wet weight, which is here, but you don't have to dry all this soil to do a wet weight minus dry weight, because to have the amount of water, the weight of water in this wet soil, for example, you have to do the wet weight of this soil, wet soil, minus the dry weight of the soil. In that case, you will obtain the weight of the water in this soil, in this wet soil. So we don't want to weight all the whole soil. It's too much. To do that, you just use this kind of plate. Of course, you cannot use plastic because you are going to dry it. Use this kind of plates. First, you have to know the weight of your plate, because as you can see, they are different shape, different size. You weight the empty plate, these plates, okay, and you put, or if you don't want, you don't even need to weight the empty plate. Also, you don't even need, because just put the wet soil inside in this plate, okay. As you can see here, we have 6 plates. It means we did 6 tests, and this is me actually. This guy here is me when I was bachelor student, okay. We did at that time six tests. These 6 tests, by changing the unit, the water content for each test, okay. You just cut a small portion of this soil, this wet soil, and put in a plate like this, and go and weight that plate with the soil. In that case, the weight you will obtain is the wet weight of soil plus this plate, both of them at the same time. This is in the case you don't have the weight of the empty plate. It doesn't matter. Just get the weight of the plate plus the soil that is inside. Okay, then dry it. If you dry the soil even one day, After drying it, all the water will go, and you will weight it again. And obviously, the weight you will obtain will be less than the first one. In that case, it means you can obtain the weight of your water by doing wet weight minus dry weight. Okay? And if you have the weight of water divided by the weight of the soil, you can obtain the water content. I think you know how to calculate the water content of soil. So you do this for several tests. As you can see here, the arrow is coming back here. After doing this, after putting, you wait, putting the amount, certain amount of soil in the plate, and you put it in this oven. Weight it first with the soil with the plate, and you can see inside there is small paper. You write the test number, or on the plate itself, I don't know. That will be depend on you. And then you continue again. You add more water in this still wet soil. You add more water, and you mix again very well, and you continue doing three layers, 25 blows for each layer, and come back, make it flat, wait again, calculate the new wet weight. It is supposed to be higher, and take a small amount of soil, put in the oven again. Okay, so sometimes you cannot do the test within 1 day. Sometimes you have to do like 2 days, but not even sometimes, because this soil will take time to dry, at least 1 day. Dry it so that all the water will go. Okay, you do this again and again for depending on the number of tests you want, and that's it. And just for your information, instead of using your hand, this kind of machine exists now to do it automatically. Just push the button and the machine will do it. You can buy online. Okay, this is somehow how this test work. And now, how do you obtain the energy? The energy of compaction, the effort of compaction. Because doing this test in the lab is just to obtain, the objective is to obtain the maximum dry unit weight, and then obtain the optimum water content. Okay, and we have then to go and try to obtain the same value, same dry unit weight on the construction side by using the approximately the same water content, optimum water content. Okay, because after doing the test in the lab, you know now the optimum water content for this soil, for your soil you have. But to obtain the maximum dry unit weight, you have to use the same compaction energy. The same compaction energy, so that you will obtain the same dry unit weight that's in the lab. Because if the dry unit weight obtained on the construction site is less than the one you obtain in the lab, means your compaction is not good on the site. So you have to do it again. And this is also the way of quality control, way of doing quality control. We will talk about this later. So this is the mold we are using, right? So we know the volume, we know the height, from which height this hammer will drop, and we know that there are 3 layers, 1, 2, 3 layers. And we know that the volume of the mold is 944 cubic centimeter, about that. Okay. And 25, the weight of the hammer is 25 kilograms. Okay. And the hammer is dropping from, sorry, this is not 30.5 again. Please, I corrected it before, and this time also, please remember, it's 305 millimeter. Actually, the exact value is not that even. This is just approximation. So, and remember also, 25 blows for each soil layer. By knowing that, we can calculate the energy used in this test, the energy used for this compaction. Okay, how to do that? Here is the compaction effort. This is the weight, the exact weight, 2.495 kilogram. This is what we are saying here, 2.5 kilogram, just approximation. The exact weight is here. So you multiply this weight by the gravity, G, 9.81 here. Okay. Maybe you can delete 1/8, just 81. We'll fix that later. Some people will take 10, but 10 is not the right value actually. Okay. And you multiply this by this height, because the true height is actually 304.8 millimeter. Of course, you have to convert this height in meters. That's why we have here 3048. You see? Okay. So weight M multiplied by G will give you the weight in Newton, multiplied by the height, that is energy actually. Okay. But don't forget that we have 3 soil layers. That's why we have to multiply it by 3. And for each soil layer, we drop it 3 times. So once you pull it up, the energy it has, this energy. But you drop it 25 times. And 3 times 25 times. So you have to multiply by 3 layers and 25 blows per layer. Okay, divided by the volume to have the energy by unit volume. The volume, as you see here, you convert this cubic centimeter in cubic meters. Okay, so I'm not sure if my calculation is good, but maybe you will get around this value. Okay, this is kilojoule, not L. Please let me correct this, then we continue. Okay. Okay, correct it. So this is in kilojoule. Okay. But please check this value. Anyway, the value here is not what is important for me. What is important for me is to show you how to calculate this. You can do this calculation by yourself and check by yourself. Okay. Yeah. Okay. And after this, you know the energy you have to use per cubic meters. And after getting this energy, you will use this to calculate and estimate the speed of your compaction machine on the construction site. Okay, because you will use this to obtain, when you use this machine, for example, this compactor, to compact the soil, or this is asphalt. Okay, so you know the energy of this machine, and you know the energy necessary for compaction of 1 cubic meter. So knowing that, you will tell the driver, please drive this speed and do how many rounds, like 1, 2, 3 times. Okay, it based on the energy you need to obtain the maximum dry unit weight in the lab, and the energy that this machine has. Okay, each machine has its own characteristics, so it's difficult to tell you here the speed, or this need to be like in very specific case, because when it is running, you see the soil will, the space within the soil particles is reduced, and it is compacting, something like that. See the force, the amplitude of the force, depending on the speed and how many times this machine will pass on this soil. See, the asphalt will be well compacted or not, depending on that. Okay, but if you know the energy you need for per cubic meter, and this is important to precise this, because if you know the soil layer, for example, this layer, if you know the layer of this soil, this asphalt, for example, or this soil, now this time this asphalt is being compacted. So if you know the height, the thickness of this layer, then you know what length you need to go to get 1 cubic meter. Okay, so anyway, this is how it is used. And more, for just for your information, there are other type of compaction. This kind of compaction, this compaction is static compaction. This is not really famous. Maybe some people don't know even this, but this is also another type of compaction. This is just a static weight on the soil, and that's all. You just leave that weight on the soil and keep it like that until a certain given time, and this will compress. Okay, just compress this statically. It's not like dynamic, you drop hammer. No, not so famous. Mainly people use this type. Okay, all right, I hope you know how to perform this test and how to obtain the energy of the effort of compaction. Okay, so let's continue. Let's come back, go back to this figure, this plot, the water content versus dry unit weight, like this. Okay, this curve, how do we use this curve, and how do we obtain this curve is I have explained already. So for a given unit weight, a water content, for a given water content, for example, now we will try to talk about this part, because so far we didn't talk about this part of the curve. What is this part? For a given unit water content, the degree of saturation S, the dry unit weight of compaction can be calculated by using this formula. We obtained this formula from chapter 3. If you remember, go back, you can check equation 3.17. So we can obtain the dry unit weight also from this formula. by using the specific gravity, GS, unit weight of water, that is easy for you. And of course, this one, void ratio, the E void ratio. Okay. So if you have this formula now, and you have this one also, it means you can work to obtain something with this formula. Or we have this formula also, degree of saturation multiplied by the void ratio equal to specific gravity by multiplied by water content. This equation also, we have explained this in chapter number 3. From this, we can obtain this E. Okay, the void ratio can be obtained from this equation. So if we have this void ratio now, what can we do? We can replace this void ratio in this formula. This formula of void ratio, specific gravity by unit by water content divided by degree of saturation. We can replace this void ratio here. Okay. Then we will obtain the dry unit weight. So if we have this formula, 6.3, I will keep it here. Okay. So it means we can obtain the dry unit weight from this equation 6.3 as well. And what do we do now? We consider when the degree of saturation is 100%. Okay. So for a given soil, a given water content, theoretically, the maximum dry unit weight is obtained when there is no air in the void, in the spaces. And that is when the degree of saturation is 100%. What does it mean exactly? When you add a small amount of water, the water is going to occupy some void in the soil. Okay. Then what you do, the water will just play the role of lubrication. And then you have to reduce as much as possible the void that are not occupied by the water by doing the compaction. When the soil was dry, means no water, it's difficult to compact. Then you add just small water. This water you add will occupy some void, but not 100%. Suppose that not 100% of the void are occupied. That means the soil is not saturated. Then the remaining voids, it's you now, by doing the compaction, you will reduce these voids. Supposing that you succeed to reduce all the void in the soil, the voids that are not occupied by the water, then your compaction will be perfect. It means no void at all in the soil. And it means all the void are occupied by the water, and the non-occupied void by the water, you have compacted soil to close those void also. That technically it means the soil is saturated. Okay. Soil can be saturated only if all the void are the air are there is no air in the void, in the spaces. In that case, it means the degree of saturation is 100%. Then the maximum dry unit weight can be obtained from this formula. It means S is 1. 100%, degree of saturation 100% is 1. Then you can just transform this to 1 and you obtain this formula. Then by simplifying, you can obtain this. Okay. This JS, specific gravity. To obtain this here, you have to divide it by 1 divided by specific gravity. Then you can eliminate this one. This is simple mathematical relationship. I think you understand this. Okay. So this one is when there is no void, no air in the soil. This unit weight, this dry unit weight. So 0 air void unit weight. 0 air void unit weight. Okay. This 0 air void curve is here. This is what we are calling this curve. 0 air void curve. This curve. And to obtain then this one, it is here with the moisture content. You use this following procedure. Determine the specific gravity, the GS, for you need it. That is 1. Number 2, you know the unit weight of water. That is known by everyone. Number 3, assume several water content. The value of W, 5, 10, 15%. Okay. Then you use this equation number 4 to calculate the unit. It means for each water content, you can calculate this gamma Z AV. Okay. It will give you this curve. And this figure is showing this curve, the variation of this gamma for each water content. Okay. For each water content, you can obtain this variation. And under no condition, no circumstances, you can get this line in this compaction. Okay. Any part, there is no any part of this of your compaction curve that can touch or go back. Even touch maybe, but even touching is very difficult, almost impossible. Like this curve coming and touching here, no. Okay. This right side, it's impossible. The limit is here. It can, if your compaction is very good, maybe you can come close to this, very close. But going the other side is impossible. Because that means because this one is, all the void are already, all the air is empty already, no air at all. This line means. So you cannot go above that, of course. That is what is this sentence is saying. Okay. I think that's all for this video. Just remember that after this video, all the rest of my videos will be private. So please contact me. You have the email here, you have my WhatsApp, or just send me write a comment on any video and it will be okay. Okay, if you would like to continue watching. Thank you for your time and looking forward to receiving your message.